I have to break from the norm of my usual tutorials today and give you guys a semi-quasi tutorial, sort of, and a myth debunker. Um, I've come across this image and others similar to it on the internet lately. And in case you don't know, this is James Holmes, the suspected Aurora, Colorado movie theater shooter. Now, as you can see in this image, people have been wondering whether or not the two people in the image are the same person. And as you can see, the nose is wider on the image. The ears don't match up. The jaw is slightly narrower on one image, and the eyes are said to be a different color. Now, as for the eyes, that's a simple explanation. That could be just a saturation issue or something like that. But the rest of them I'm going to address. Now, I do want to state for the record that I do think there are a lot of unanswered questions out there regarding this case, but this is not one of them. I believe I will demonstrate beyond a doubt that the two men pictured in this image are one and the same. I know there will be haters anyway, but feel free to discuss it in the comments if you want to. I won't block anyone from saying what they want, even if they disagree with me. Now, since I usually make 3D modeling and visual effects tutorials, I will attempt to demonstrate how focal length plays a part in the anomaly we see here. What we're going to discuss is perspective distortion and how distance changes perspective and how focal length plays a part in that as well. And what I've got here is three visible things in my scene. I have a camera, a girl's head, and for perspective, I have Suzanne the monkey behind her. Now first, let's look at the camera settings. If this were in the real world, it's good to know things like our sensor size and the focal length of our lens. To begin with, we're going to set our focal length to 35 millimeters, and our sensor size will be full frame 35 as well. There are presets for different cameras, so we use the Canon 5D Mark II preset. Now up in my right hand corner, I have the camera's perspective or point of view, and if I grab the camera and move it toward my subject, you can see that the girl's head is slowly getting bigger than the monkey in the background. And that's because closer objects appear larger than further away objects. And it's the same reason the moon looks bigger than the stars, even though we know the stars are way bigger than the moon. Now, let's go ahead and render the image out to slot 1, and I'll pause the video and come back when it's done. Okay, it rendered. And now let's move the camera back. We can see the monkey is starting to look bigger than the head now. Now let's adjust the focal length. And notice as we adjust the focal length up, the perspective doesn't change. The monkey looks the same in size in relation to the head. So we can see that focal length does not change perspective. Now let's go ahead and render out this length to slot 2. And the render is done. Now let's switch between the slots. As we switch to slot 1, you can see the monkey gets smaller because the head is closer to the camera. And when we switch back to slot 2, the monkey is bigger. But you may also have noticed the distortion on the face changed as well. The cheeks seem wider and not as narrow. Let's switch back to 1. The face just got narrower again. Now this is fine and dandy for a computer-generated image, but does this distortion happen in real life? Well, I have a few real-life examples to show you. First, let me show you an image strip used with permission from Daniel Baker. Thank you, Daniel, for letting me use this. You can visit his blog by clicking on the link below in the description. And as you can see here, Daniel took photos of himself using different focal length lenses, 85 to 8 millimeter on an APS-C sensor, so it's a little bit smaller than a 35 millimeter. And so that's really equivalent to 127.5 to 12 millimeters on 35 millimeter film. And he took that from 5 different distances between 220 centimeters. So I also want you to take note that the wide-angle lens used for the last 3 photos is not a fisheye lens. You can clearly see the distortion on the 8mm frame. Notice he has no ears. Yet, in the less distorted 85mm frame, you can clearly see he does indeed have ears. And we're happy that he does, because that would be just awful, walking around like a freak with no ears, yelling, "Huh?" all the time. Now, moving back to our image of James Holmes, remember the accusation about the difference in his ears? Yeah, it's starting to make sense now, isn't it? Now, let's look at another example. This one is used with permission from Stephen Eastwood. You can visit his website at stepheneastwood.com/blog, and a link will be in the description as well for that. Now, notice once again how the face is distorted. The face on the left is much narrower at 19 millimeter than the face on the right at 350 millimeter. Once again, let me show you 2 more images I took back to back. The first one is a focal length of 27 millimeter and taken at close range. The second one is 135 millimeter and taken at a distance of about 8 feet or around 240 centimeter. Now, switching back and forth between them, you can see how the face gets narrow and then wide. But you may also notice that the nose doesn't change shape that much. So how do you answer the question about the shape of James's nose? Well, someone suggested that when you smile, your nose widens. Now, at first thought, I rejected this notion because I figured that it might widen a little, but it really wouldn't widen that much. So I put it to the test, and to my surprise, they were right. Here's a video of me going from smiling to not smiling. As you can see, my nose does indeed get much wider when smiling. So I hope this clears this rumor up once and for all. My conclusion, the 2 men pictured here in this image are indeed one and the same person. So if anyone you come across brings up this argument in the future, just direct them to this video. I thank you for your time, and once again, I would like to give a shout out to Daniel Baker and Stephen Eastwood for allowing me to use their images to help make this video.